Please pause the video and take a moment to read this important safety message. Alright, finally, our updated Analog Discovery 2 dummy load box set up using the Audio Analyzer Suite software from TheStuffMade. If you guys may have remembered, about a year ago, I started making a video series using the Analog Discovery 2 from Diligent. And we were kind of working around with it on the bench using this software from TheStuffMade. And it was looking very promising, and then all of a sudden the software stopped working. You couldn't download it anymore, and those that had already downloaded it, when you tried to run it, it tried to look back to his website, and ultimately it would fail and the application would die. So we kind of abandoned the project because of that, and we went back to using other tools. Well, here about a month and a half, 2 months ago, the guy at TheStuffMade finally updated his software, and he's got it all working again, and you can now download it again. And so we have been working with it ever since then, and we're really happy with the results. So what we're going to show you today, one, a diagram of how it's all wired up. I've drawn a new diagram. I've uploaded it into a Google Drive, and I've shared that folder, and I'll put a link down below so you can just download a full-blown picture of this that's not fuzzy. Two, I'm going to take you over on the bench and show you how I physically wired all this up. So even if you grasp, number one, the conceptual logical diagram, number two, we'll show you how I physically did it. And then three, we're going to put all that back together, hook an amplifier up to it, and we're actually going to utilize the software and see how all that works. So if that's exciting for you, stay tuned. We're going to try to do all this in one video today. Okay, as you can see here, we've got an updated version 2 of this diagram from February 2019. If you used any of the previous versions, please throw them away and or adjust your build to this new diagram. Okay, so what you see here inside the purple box is actually my dummy load box, and the box is somewhat irrelevant what you put it in. I've seen a couple of different people build my setup, and they've used different style boxes. And then outside the box, what you have here is your amplifier or receiver, and you also have your speakers. Okay, so the way this is going to work is on the edge of your box here, we have put a set of banana plug jacks, one for left and one for right. And you simply come out of your amplifier or receiver and use a set of wires that plug into these banana plugs to feed in your right speaker output and your left speaker output. So basically the way this is going to work is you're feeding the output of your amplifier receiver into these jacks. Okay, what happens then is internally these jacks are then wired over to basically a switch. Okay, and what this is a dual post, dual throw switch here, and what it's really doing is just switching you between an 8 ohm and I would recommend a 50 watt or more resistor. I'm using a 250 watt 1% Dale resistor, but there are other options out there for you. So that's wired across one set of the dual post dual throw switch here, and then across the other set here we take it over to another set of banana jacks that take you outward then to your speakers. So you just plug your speakers into a set of speaker wires that have banana jacks on the other end. And we do the exact same thing on the right channel. So really all this switch does is switch you between feeding the output of your amplifier through this dummy load, which you would want to use for most of your audio testing, versus a highly inductive and changing load here when you're actually playing it through the speaker. But there's points in time where you actually want to hear your amplifier, so you flip it over, flip the switch over to the outputs here. Okay, and then what you're going to want to do is you're going to want to use the Analog Discovery 2. By the way, this device you can buy from Diligent. It's $279, and there's a lot of things you can do with one of these. It's a full-blown both oscilloscope and waveform generator all in one little package. But you also need to buy this little device they call the BNC adapter for the Analog Discovery. And it basically just plugs in where the normal pinouts would go in the Analog Discovery, and it allows you to connect BNC connections such as an oscilloscope probe. And this little device is $19.99. So you're about $300 into one of these things plus shipping. And the way I did it was I fed USB from my PC into this, and I will call out that one of the issues I was having with this was the length of this USB cable. I was running about a 16 to 17 foot USB cable from my PC over to this, and I was having some challenges. And so what I ended up doing was having to use a powered switch, USB switch, somewhere in the middle. So I ended up with like a 12-foot cable or 10-foot cable, a USB powered switch, and then another 10-foot cable to get to this. After that, all things were good. And I'm also using a little power supply that they sell for the Analog Discovery. It's a 5-volt, 2.5 amp switching power supply, and it's $12.99. And what it does is provide power to the Analog Discovery all the time so that it doesn't have to feed from USB, and allows your USB signal to be cable to be much longer. So I'm feeding from the wall into this, and I'm feeding from my PC into this. And then basically on the other side, what you've got is you've got an output here that's titled W1 and W2. So that's waveform generator 1, waveform generator 2. And that's where I had made a mistake in an earlier drawing. The way the Analog Discovery 2 works with the software from TheStuffMade, it only uses waveform 1 for most of the test. We'll get into that a little bit later. But you can see here I'm feeding out of waveform 1 into basically a little RCA 3.5 millimeter stereo jack. So part of this is you got the outer going to ground, and then if you'll notice here, I've tied right and left together. So I've basically made this a mono setup, and then I'm feeding out of my RCA jack into a splitter that goes into just a normal set of RCA cables that feeds the input of the amplifier the exact same signal on both sides. So this is really mono all the way here into right and left channel. So if you think about that, we're generating a waveform here. We're feeding out through waveform generator 1, kind of combining the signals on left and right, feeding it over, feeding it into the amplifier. Then we're taking the output of the amplifier and we're bringing it over here and we're tying it across these two dummy load resistors, okay? Well, then what you're going to do is you're going to take channel 1's input here for the Analog Discovery 2, and we're going to take it up via this blue wire, and we're going to take it here to the left speaker. And you notice I just tied across it, kind of one side to the positive, the other side to the negative. And we did the same thing here with channel 2. We brought it up and we tied the positive side here and the negative side here across this 8-ohm dummy load. So it's a pretty simple setup if you think about it. The software sends a signal to the Analog Discovery 2, which then drives the input of your amplifier. Your amplifier then sends the signal out across the dummy load, and then you're just basically measuring what's coming out across the dummy load here back into the Analog Discovery 2 and sending it back to your PC. So what you're really kind of comparing is the input of your amplifier to what's coming out the other side of that, and that's how it makes these nice measurements. Now, one other piece of complication I've added to this is that I put another set of a few B and C jacks here into my dummy load box. The reason I want that is so that I can feed other devices. So you could have a voltmeter you might want to feed. You could feed an oscilloscope if you actually wanted to watch the waveforms. You might want to feed a frequency counter. Different types of devices that you might want to feed. And what I've done is I've tied all of those together kind of in a mono mode, and I've fed them over then. And what I'm doing is I'm really just going into another dual post, dual throw switch here. And if you flip it one way, you're measuring across the right speaker. And if you flip it another way, it comes up via these green and brown wires, and you're reading across the left speaker. So really the left-right switch is just for these common outputs right here. So you may want to watch the waveform on the left channel. You may want to watch the waveform on the right channel. You could do this differently. You could put one of these for left channel, one of these for right channel, run it over here, wire it up, and then you could watch both channels of your amplifier on an oscilloscope at the exact same time if you chose to. So that's it. Let's go over and take a look at this on the bench and how we wired it all up. Okay, as you can see here, what we've got is just a metal chassis, and you can use any metal chassis you want. This one's about 18 inches wide, about 12 inches deep, and about 1.5 inches high here. And what it was originally was an HP BNC switch that I found at a Hamfest for like $5, and all I did was I gutted it. It had this electronic circuit board in it. I gutted all that out. All I really wanted it for was a chassis that had BNC mounts across the front of it. But you could take any chassis and just mount your own BNC connectors on the front of it, okay? So from there, what we've done, as you can see here, I have mounted 2 large power resistors inside this chassis. These are Dale RH250s. They're 250 watt, 8 ohm, 1% resistors. And they're really good for this type of work. However, you don't have to use these. These have gotten really expensive these days. I'll put a link down below where you could find some other types of dummy loads, but resistors. But what you do want to use is something that's 8 ohms, probably larger than 50 watts or more. And you want something that you can mount to the chassis, and I used heat sink grease to actually mount these down onto the chassis so that they conduct their heat outward across the whole chassis. Helps dissipate heat, helps them get their full rated power output. Okay, up next what we've done here is we have mounted the Analog Discovery 2 device along with the little outboard BNC adapter. And what I've done here is I took and found 2 little standoffs and screws, and I actually mounted them through the holes that were already in this BNC adapter. And so I kind of mounted this down, and then I kind of pushed the Analog Discovery onto it, and then I used some 2-sided tape on the other side of this Analog Discovery 2. And this thing's solid as a rock. It's not moving anywhere. And then you can see here where the USB connects and the power cord connects. And if you'll notice here on the back of the switch, I made a little cutout in my panel here to be able to feed those 2 into this device, okay? And then on the front side here, as you can see, what I've got is just a bunch of BNC connectors going across it, and then a few switches. And we'll get, you know, we showed you all 3 of these switches earlier, but we'll walk through it a little bit more here. And then you can see here where I actually wired up a 3.5 millimeter RCA jack, and as you can see here, I can unplug this little device here, and the other end of the cable that I use is nothing more than a little connector here that then goes to right and left stereo RCA inputs that I feed into the amplifier. So basically this cable is what takes the output of the waveform generator and feeds it over into your amplifier. Your amplifier then feeds it back and comes back in through these speaker jacks back here. We'll talk more about that as well. Okay, I thought it might be easier to start on one end here. So this says right, and I just kind of wrote it on my little device here, but it's just a set of banana jacks, speaker jacks. And what I'm doing is I'm coming off the other side of those with just some wire that I've twisted up, and I'm feeding it over to a 3-lug terminal strip here, as you can see. And the center is grounded, so I'm not using the center lug. But basically I brought it over here, the green being the positive and the black being the negative. And I just kind of tied it off at that point, okay? And from there, what happened is I'm feeding it into the center of this little switch right here. Okay, that lets me flip up or down. And really what I'm switching is between dummy load and speaker, okay? And so basically one side of this then comes out and it feeds over this green wire, and it comes over here and it goes to this second set of speaker jacks right here, another set of banana jacks. And what this feeds to is my actual speakers that I keep above my bench up here. And I just use a set of Clips RB81s above my bench here as my set of bench speakers. There's really nothing special about the speakers other than they're just a good set of efficient speakers. So when I'm working with, you know, single-ended tube amplifiers, they actually sound really good. And then the other side of this switch right here, what I'm wiring to is basically, if you'll notice, it comes right over here to this little 3-lug adapter that I've got right here. Another same little 3-lug terminal strip. There again, not using the middle. And one side of that feeds over and goes to this lug right here. The other side of this feeds to this lug right here. So basically I'm just feeding across this dummy load. So as I flip this switch, ultimately my input coming in right here is either coming right back out here or it's coming across this dummy load, all based on this little switch right here. And if you were to go look at the other side, the exact same thing. Feeds in, comes down, goes to a 3-lug little terminal strip right here, left and right switch, and you can see I've got it labeled here, dummy load and speaker. And then from there it would either feed you right back out this little set of speaker jacks right here, which would ultimately be my left speakers, or it feeds you over to this little terminal strip right here. And then from this terminal strip, what I've done, same thing. I've came to one side of this resistor to the other side of the resistor, and so you feed across. So flip this switch, you're choosing to go back out to the speakers or across this resistor right here, just like we showed in the diagram. Okay, let me walk you through now the how the Analog Discovery 2 is wired up. And if you can see here, this is labeled 1 and this is labeled 2, and this is really just waveform generator 1 and waveform generator 2. Remember, for most things we do with the Analog Discovery, it only uses analog waveform 1. In other words, when you're testing a stereo amplifier, you need to feed both sides, left and right channel, with number 1. Now you could do that 2 different ways. One, you could run a single BNC cord, and I am using RG316 coax here that's nice and shielded. And I'm running it over and I'm feeding it into this little jack. And this jack has basically 3 little connectors on it. One of those will end up being its ring tip sleeve. One of those ends up being the ground, and then the other 2 end up being the tips, which are the actual left and right channels. So you could just come out of this with a single piece of coax, come over here, feed the ground into the proper outlet, which is the middle one, and then you could take the center conductor and you could feed it into both sides here, and that would give you out the front here, feeding the output of 1 into both the left and right channel. In other words, a little bit of a mono conversion the way you wired it up here. I decided to run 2 pieces of coax over instead and join them via a BNC T connector right here. As you can see, it just comes out, it comes into a little T connector, and then I fed over here the other side and fed it in. So I'm basically doing the mono conversion right here with BNC connectors. You could just do it with a single run, but then you'd have to run the center conductor of the coax or whatever you're using to both sides of this. I did have somebody, I posted a picture of this at one point a little bit back, a few weeks ago, and somebody kind of commented on the picture, wow, I don't see how you're not having problems with all these wires just running around in here. Well, here's the secret. The signals coming out of the waveform generator are very low, small signals. So you want to feed those inside of some type of shielded cable like this coax I'm using, out through this shielded cable here that goes to the amplifier input. But when it comes to what comes out of the amplifier and is feeding into this unit and going across either the dummy loads or the speakers, those signals are large enough you really don't have to worry about noise getting into it. So as long as you use coax or some shielded wire on the front end here, you will be fine. Okay. What I did with the second jack here is I just ran it over here and I tied it into, I had a bunch of extra BNC jacks, as you can see here. So I just took jack 8 right here and I made it W2, just in case I ever needed it for some other type of wire up in the future. There's an IMD setup that you can do with this where you have to do a little bit of reconfiguring of this if you're wanting to do intermodulation distortion. And so by having that extra jack over here fed with waveform 2, I'm good to go for that type of measurement. Okay. And then really all you've got to do is feed the output across these dummy loads, which if you'll remember, going across the dummy load, I had came over here to this little terminal strip, and this little terminal strip. This terminal strip feeds across this. This terminal strip goes across this. Then it was as simple as taking the right channel here, feeding again with some of this LM316 coax, and I took it over here, and as you can see, it just feeds, and I soldered the outer shield here to ground and the center conductor here to the positive. I did the exact same thing over here on this. So this feeds over here into the left channel. So both my inputs and outputs of this are kind of using this shielded cabling here. And then really all that's left here is this little switch that I told you earlier, and that's where I'm feeding across, as you can see down in here, for all the rest of these across here, right in here. So number 7 all the way down through number 3 here, they're all wired together. I used just a piece of Romex house wiring, probably number 12 gauge, to wire these center conductors together. And I used another piece of Romex to wire the outer conductors together. And then I'm just kind of feeding off of those coming over here to the switch. In other words, and then I'm taking that out across both of these 2 outputs right here. So if I flip this switch right here, jacks 3 through 8 right here would be reading across the left channel. And if I flip this switch down, jacks 3 through 7 here would be feeding out over this little jack right here, which is ultimately across the right channel. So keep in mind, jack number 9 I've got right here, I converted it to this 3.5 millimeter RCA jack. 8 I had fed to be waveform 2. 7 through 3 here are the common ones that go to the switch that would read across either one of these dummy loads. And then I did a little something different here with number 0 and 1 here on this switch. Okay, what I did was I took one of them and I fed it over, and I'm reading across the right channel here, and I took the other one and I fed it right here, and I'm reading across the left channel. And what that'll let me do is plug an oscilloscope into right here, left here, and so I can watch on my oscilloscope the outputs across both of these simultaneously on a single oscilloscope using a dual channel scope. So that's all there is to it. I know it looks like a good little bit of wiring, but it's really not that complicated if you break it down. And really the only place I deviated from the diagram I showed you earlier was I did split out so I could feed both, watch both left and right channels here with an oscilloscope. And then I did my split out here versus doing it right here at the jack, the way I may have drawn it into the in the diagram. Either way will work fine. This just gives me some flexibility in the future if I wanted to. And that's kind of it, guys. All I've got left to do really is label the front of my panel. I've got it kind of written across the top here, as you can see my chicken scratch, but I really just need to get my label maker out and put some labels on the front of this. But let's get it all hooked back up, get an amplifier plugged into it, get the power and the USB to this, and we'll play around with the Analog Discovery 2 software some. Alright, let me walk you through my audio bench setup. So right here, what we have is our dummy load, and it is really the central nervous system at this point of my entire audio bench. And I'll walk you through all the pieces I have on my bench. You may have some of these pieces, you may have none of these pieces. Really all you need is the dummy load and the software, that audio analyzer suite software. That software replaces most of the gear I've got here up here on this bench, but I'm going to walk you through it anyway. So below the below this dummy load switch, I have the HP 8903 audio analyzer, and if you'll notice here, I have wired kind of coming out of my dummy load here, number 7, which was one of those common ones. I've wired it into the input of the 8903, and then I've got this little place over here that all I would have to do is unplug this little jack from the front of this and plug it into here, and all of a sudden I'm using the 8903 to do my measurements with. So it makes it really simple. I'm also feeding out of this here on pin number 3, which is another one of the common ones. I'm feeding up here into the HP 3582 spectrum analyzer. And if I flip right or left switch here, I would either see right or left channel on the spectrum analyzer. Okay. Up here we've got a Syncor PA81 stereo power amplifier analyzer. I don't use that a ton. It has some built-in 200 watt, 250 watt dummy load resistors and whatnot. Every once in a while I use it, especially on some preamp measurements. This device down here, just nothing more than a simple Tektronix 2246 oscilloscope. And if you'll notice, I've got my right channel feeding out here and my left channel feeding out here. You can see the red and blue. Then you can see the red and blue here, right channel, left channel. So at all points in time, if I turn this scope on, I can then measure the output of whatever's going through the dummy load across left and right channel here on this oscilloscope. Okay. Similarly, over here, it's nothing more than a high voltage power supply that I use for various bench testing. Hidden underneath of it is a Tektronix CFC 250 frequency counter. It's nothing more than just a digital frequency counter, and it's kind of hidden behind my little camera mount head here, so it's kind of hard to see, but it's sitting down there at 0 hertz right now. So whatever I do through the dummy load, as it sweeps or changes frequencies, I can see the readout on it right here. And if you'll notice, I'm feeding that back over here off of this pin right here, number 2. It comes over, it feeds around, and it goes into this BNC connector right here. Coming out this T-joint on the other side of this BNC connector, I feed up and input into this Fluke 45 dual display multimeter here, and I just leave it set on volts AC so I can kind of read the voltage readout of what's going on. This is a B&K Precision, nothing more really than just a function generator that has a built-in frequency display on it. And I can take the RCA cable out of my other unit and I can plug it in right there, and I can just feed for ad hoc type of measurements. One thing I do like about this is it lets me do all sorts of different types of waveforms. So I can do square waves, sawtooth waves, trapezoid waves, all types of different waveforms. So I use this a lot for just ad hoc feeding of signals. Over here I've got an AM/FM stereo analyzer, the SG80, that I use from time to time when calibrating AM/FM. And then down here really all I have is a Variac that's kind of got a built-in current meter and whatnot into it. And it's also got a dim bulb built inside of it. So coming back over here to the central nervous system, okay, feeding out the back side of it. Let me pan up here a little bit. You can see hidden up here along with the scope and some other bins that I keep stored. I got a couple power supplies up here, just some bins I keep things in, a Rigol oscilloscope I use from time to time, but more importantly, just a set of clips. These are RB81 reference speakers, as you can see. And I've got a left one here and a right one on the other side. And so what's happening is the right channel of that is feeding back down here into the back of this dummy load, and the same with the left speakers feeding into the back of this dummy load. And then what I've got is, I'll take you down here and show you, on the bench itself down here. You can see this right here. I've kind of got them bundled together and labeled right. I've also got them labeled right here. This is what I would plug into the back of an amplifier that feeds up into the right side of the dummy load. So you can see right here on the back of the single-ended KT88, we would just feed here and here, okay? We've also got feeding down the left channel here. Kind of comes down out of the bench. We'll feed it over here and over here. And then coming out of the bench, we've got the left and right RCA jacks. So we can plug that in, and then what we'll do is we'll move over here. We'll actually hit the power switch here on the amplifier, and I'll have to turn on the power to it, and we should have, let's see, yay. We've got blue light on the front of the amplifier now, and as you can see, everything is now wired up and good to go. And what we're going to do is we're going to go over now and run the software remotely. And let's test out this the single-ended KT88 amplifier here. Sam, I think it turned out really well here with the little blue LED on it or whatnot. But that's as simple as it gets. I mean, every amp I pull up on the bench, I just grab those two banana jacks back here. I grab this RCA cable that feeds into it, and everything else is kind of, you know, at that point, kind of all set up and ready to go for you. Like I said, you don't need all this other equipment. The audio analyzer suite replaces the 8903. It replaces the 3582. It shows you the frequency on it. It shows you the voltage on it. And it has an oscilloscope output. I do like being able to see it over here, but it's a lot of bang for your buck for a free piece of software on a little $300 device. I can tell you that. Alright, if you go to YouTube and just type in the TheStuffMade Audio Analyzer Suite and do a search, it'll bring you up to this video. And it's titled the Audio Analyzer Suite 1.0.0.75, available for download. I'll also put a link for you in there. But in here, the TheStuffMade kind of goes into the details on how to install this, or where to download it and how to install it. There's a lot of comments here on that. There was some of the ways work better than others, but I'll let you kind of follow through that and get the software installed yourself. But once you get the software actually installed, what you end up with is this right here. It's the Audio Analyzer Suite, and there's a bunch of tabs across here, okay? The first one is THD plus noise versus frequency, and we use that one a lot because what you're trying to figure out here is you know, how your amplifier is performing you know, total harmonic distortion across the frequency spectrum. So some amplifiers may have very little distortion on the high end, but a lot of distortion on the low end, and or vice versa. And then there's THD versus power, another very useful measurement. You know, a lot of amplifiers will work great at 1 watt output, but when you start driving them a little bit, you know, at some point your total harmonic distortion starts getting out of hand, and that's typically when you're reaching the maximum output of your amplifier. So kind of tell you how hard you could drive your amplifier and how it actually performs. So there's a tab here called IMD. And IMD will not work the way we have this unit wired up. I mentioned earlier you have to use waveform generator 2, and you have to feed both inputs and the outputs, and you kind of have to look for any implications between the two. And so maybe I'll make another more advanced video on that down the road. Frequency response I use all the time. This will tell you how your amplifier is performing across the frequency spectrum. In other words, does it stay flat across the whole frequency spectrum, or is it attenuating the low end and attenuating the high end or whatnot? Output impedance and input impedance are two other measurements like IMD that you would need to wire it up differently, but they don't get used very often. The same IMD is really kind of hey, you're playing something in channel 1, left channel, and a big bass note hits. How does that affect something going on channel 2 or your right channel that might be playing at a different frequency at that point in time? And then you've got spectrum analyzer, the same as the HP 3582, and then you've just got a general oscilloscope. So let's play around and use all of these. Okay, we're going to do a THD versus frequency measurement here. The default is 20 to 20 kilohertz. I'm going to leave that alone because that covers pretty much the entire audio spectrum. Steps here can kind of let you choose the number of data points along the way, and 50 is fine. Usually the average is on 1. You can change the amount of power you're feeding. So we're going to do a measurement at 1 watt across, and always make sure that you're matching up with your dummy load here at 8 watts. Or 8 ohms. I do have it set to measure both channels at the same time and include harmonics and noise outside of the range. And then the only other thing you've got down here is you could click on external attenuation. Like if you wanted to put in line with your analog discovery inside of the little dummy load box a 3 dB or 6 dB attenuator, if you were running really high power, I didn't want to overload the analog discovery, but for right now, I'm just the external attenuation factor is basically 1 or none. So let's click run at this point, and since I have the unit behind me set on dummy load on both channels, you really don't hear anything. If I had it flipped to speaker right now, you would certainly hear it, and the varying inductance of the speaker would affect this output somewhat. But look, you've got spectrum analyzer down here. You've also got both the pink and blue waveforms here on the oscilloscope, as well as you've got the error waveform here. And this thing's looking pretty good and clean. So if you look at the measurements on this, all the way back here, let's see, that's 1% right here, harmonics. All the way down here, this thing crosses over the 1% mark at 35 hertz. And even below down here at 20 hertz, you're still only in the 1.3% distortion. So this thing stays pretty darn low all the way down through, and it stays below 1% distortion. Here, even at 20 kilohertz or 17, it's at 0.65% distortion. And you can see the blue and red channel left and right stayed pretty consistent all the way throughout the sweep. And so as you move your cursor along here, you can kind of see the error frequency and how this thing is performing all along the way. Okay, let's go to THD versus power. Similarly, 20 steps per magnitude is fine. We're going to tell it to stop measuring if it gets to 5% distortion. In other words, it shuts down feeding the amplifier if your distortion is way out of whack. Just kind of a safety thing. If you'll notice my load impedance, I do need to change it to 8 ohms here. And we're going to do this test at 1 kilohertz. And we're going to go from 10 millivolts up to 10 watts. And we're going to measure both channels here. So as we kind of click it, what we will see here, there we go. All right, so what you kind of got is across here your percent distortion on each channel, and this little kind of green line here is your power output. So as we cross, so this amplifier stays below 1% distortion pretty much all the way up here to about 9 watts on the output. And then down here, you know, below looks like about 0.07 watts. The distortion's up here in the even along here you can see 0.14% distortion. So super low all the way up here until you get to about 10 watts, and that's where you start getting into the little bit over 1% distortion range. Okay, up next what we're going to do is the frequency response, which is a very, very common test that I do. 50 steps is good, 10 to 50 kilohertz. I might bump this up to 0.3 or 0.4 volts RMS. That's the actual input that you're feeding in. So 0.5 or so would be line level. And we'll click run on this. And it'll take a minute. It starts the sweep. You can kind of see the left channel in blue, the right channel in red here. And you can always see measurements up here, left channel, right channel, and then it tells you what frequency it's at. All right, and what this tells you is one of my channels is a little bit louder than the other, just to the teeniest little bitty bit. But anyway, you can see the frequency response across the entire audio spectrum here is pretty darn flat. This thing, let's see here, right there where it kind of gets into the minus, okay, so I'm 0.5 dB down here all the way down at 11 hertz. So this thing's performing well all the way from 11 hertz, which is lower than you can hear, all the way up through here. So right here at 20 kilohertz, we're not even down a whole dB. We're down 0.66 dB. So this thing's performing excellently. Nice flat frequency response across the board. Up next, you can run spectrum analyzer, and you can kind of see here, this is your primary frequency that it feeds, and then you can see all the harmonics along here. One thing you may want to do here is give it a, you may want to turn on the enable button here for your test tone. Click run. And what it does then is it feeds your test tone in here at 1 kilohertz. And you can see there's a little bit here of harmonics along the way. 2K spike, a 3K spike, a 4K spike. But if you'll notice these things, look at this. See where they're at? Read across. We're more than 60 dB down at that point in time. So anything 60 dB or below here, you're really totally out of the picture altogether. And then last but not least here, you've just got a standard oscilloscope. So you can say run this thing with a sine wave, and what it's doing is showing you on the output. You're feeding the input with a 0.2 millivolt sine wave at 1 kilohertz. You could stop it. You could say, ooh, let's feed in a square wave here. And you can kind of see here. Teeniest little bit of ringing here, fairly flat, not a lot of slope to it. Really steep walls here on this. So I think it's a wonderful piece of software. I mean, all across the board, this thing just does an amazing job. THD versus frequency is one of my favorite measurements, but you know, I just think for the money, $300 and the software, I don't think you're going to come out any cheaper. You can probably build one of these boxes, I'm guessing, in the I don't know, $50, $100 less range, and you've got a full audio bench then. I am going to show you, let me go back to the bench for 1 minute. Okay, what I thought I would do next is kind of run some of the tests, and if you'll see here, my PC is all the way around here on the other side. So if we come back around over here, I'm going to reach behind me and I'm going to run a frequency speak. And what I've done is I've flipped this off of dummy load on both sides here, left and right channel, down to speaker. So you'll actually be able to hear this. So every one of those little ticks was an increment across the frequency spectrum on this thing. And let me do this. Let me come over here now, and I'm going to go to scope. I'm going to take it off of speaker so we don't kill our ears. And what we'll do here is we'll just run a square wave. And as you can see on our oscilloscope over here, we now get a nice square wave on both sides here. If I change it over sine wave, getting a nice sine wave out here. You can also see the harmonics matching up with that over here on this side. You can see here on the HP meter how many volts AC out, and it's kind of hard to see, maybe down underneath here you can see 1 kilohertz exactly. I didn't drop the camera down a little bit, you can see that better. But it's working as designed. You know, I can't even begin to tell you how great this little thing is, because if you think about it, that's a $1,000 device. This 8903, if it's calibrated, is $1,000. Otherwise, probably $700 or so, $600 for a good working one. You're $300 into a scope. You're $150 to $200 into a good digital frequency meter. You're probably another $200 or so into a nice voltmeter readout. Wow. And you're getting all that for a single $300 piece of equipment. And by the way, you can do lots of other things with too. So anyway, back over to the PC. All right, and last but not least, if you'll click the link down below, it'll take you to my Google Drive here for the audio analog discovery. You can click on this and see the picture. You can also download it and get the full-size view of it. And I also made you a little bill of materials here, which you can't see at all because it's not all within scope. But, you know, just various part numbers. Down here on the resistors, I did say I use these Dale 250 watt. I told you what I use. But I gave you another option here and a link to where to find them. I haven't used those myself, but there's some other guys that have. And I just gave you the various jacks where you'd get the analog discovery, the price, all that kind of stuff. So hope you've enjoyed this. Hope it works out great for some of you guys. I know you've been anxiously awaiting this, and we had fun making it. Thanks for watching, everybody.